Okay, we're going to start a unit on trig equations today, and we're going to start with some nice and easy ones. These are non-calculator, meaning they're going to be. It's going to be important that you know your unit circle. We've actually solved some equations like this recently when we were trying to do inverse trig functions. For example, if I wanted to show you how to do sine inverse of -1, which basically says where does the sine function equal -1. And the program that I use to generate questions doesn't have sine inverse of -1 as a question. It gives questions like this. So we've already answered some like these initial ones, some of these first few. But that's okay. It'll just be good review of something you should already know how to do. Okay, so let's start with the main idea. The theme for solving trig equations is isolate the trig function. Just like when you're trying to solve an equation, you isolate x. When x is by itself, you're done. If you're trying to solve a quadratic equation, sometimes, depending on the setup, you isolate the x squared. If you're trying to solve a radical equation, you isolate the radical. In this case, that final step will be applying the inverse trig function. But overall, the big step is to isolate the trig function. A reason that this is easy, and we'll add on to this in the next video, is that all of these are going to be the sine of theta or the cosine of theta or just one variable. We're not taking the sine of 2 theta or the sine of theta plus 10 degrees or anything like that yet. So these first couple should look pretty familiar. This first one is saying where does sine equal -1? And if you think about your unit circle, the sine, the y value is -1 only down here. And notice the domain, or the domain that they're asking us to solve on is from 0 to 360 degrees. So if you just consider one time around the unit circle, the one answer to this is where does sine equal -1 is 270 degrees. And that's down here at the bottom. One answer, and that's it. The directions might say find all solutions. As you know, there are infinitely many places that sine equals -1. 270 plus 360 in. This next one's in radians for one difference, and it's asking us for all solutions. So the question is, where does sine equal the square root of 2 over 2? Again, think of your unit circle. Sine, which is my y value, is positive up top. Square root of 2 over 2 is the middle of each quadrant. So in radians, this is pi over 4 and 3 pi over 4. All right, if you've lost some of your unit circle memory, you're going to need to get that back pretty quickly. So my two solutions are pi over 4 and 3 pi over 4, but it says all solutions. So I need all future revolutions around the unit circle. We do that by plus 2 pi in. So that's the infinitely many places where the sine has a value of positive square root of 2 over 2. So let's add a little bit of depth to these. This couple, we've got to do some steps, right? In the first two, the radical, or excuse me, the trig function was already isolated. In this one, we're going to have to isolate it ourselves. We're going to have to get this cosine alone on our own. So we start by recopying the question. All right, and so that's going to involve -3 from both sides. So on my right side is cosine. On my left side, instead of writing it top to bottom, I'm going to write it like 6 minus the square root of 2 over 2 minus 3. And now, if this is a question that's asking you for an exact answer, a non-calculator question, then something nice has to happen, because 6 minus the square root of 2 over 2 minus 3, that's not a location on the unit circle that I know. So look for something nice to happen. In this case, I need to think of 3 as 6 over 2. So now I have 6 minus the square root of 2 minus 6, which is negative square root of 2, all over 2, equal to cosine. So some sort of adding, subtracting, manipulating of terms is going to create a value of cosine that we know. So now the question is, between 0 and 360 degrees, where does the cosine equal negative square root of 2 over 2? Okay, so again, that's in the middle of the quadrants. But cosine is negative on the left, so that's going to happen here and here. And those two values, theta equals 135 and 225. I should, on my other problems, I should have theta equals, just to emphasize the fact that we are solving an equation. We're finding the value or values that make the equation true. Okay, so there's example 3. Move on to 4. Again, we need to isolate sine. So that's going to involve the subtracting of 5 from both sides. So I'm going to subtract 5, and I'm going to go ahead and call that 5 15/3. Just to kind of get the simplification rolling here. And so now I'm at 2/3 sine theta is equal to 15 plus the square root of 3 minus 15. It's the square root of 3 over 3. And now to get sine completely by itself, I'm going to multiply both sides by 3/2. Cancel the 2/3. And my equation becomes sine of theta equals, cancel the 3's, square root of 3 over 2. Again, if you don't end up with 1/2 square root of 2 over 2, square root of 3 over 2 on a non-calculator question, then something has likely gone wrong. So where is the sine equal to the square root of 3 over 2 between 0 and 2 pi? All right, so sine is my y value. It's positive square root of 3 over 2 at these two taller locations, which should be pi over 3 and 2 pi over 3. So those should be the two values that make this equation true. You can always, anytime you sub into an equation, you can sub it, anytime you solve an equation, substitute your answer back in and make sure that it's true. I'm fairly confident because I simplified down to square root of 3 over 2, which means that, this was able to be solved without a calculator, which makes me confident that I was on the right track. Okay, so what about secant and cosecant, and tangent and cotangent for that matter? They won't all be sines and cosines, which just adds one little level of complexity, but that's not so bad because if sine is 1/2, that means that cosecant is 2, so you've solved those in the past as well. You still live by the motto, isolate the trig function. So that's going to involve on this problem dividing by -2. Cosecant of theta equals negative square root of 2 over 2. Now, I can see a lot of questions arising on this one because square root of 2 over 2 is a familiar number. The square root of 2 is about 1.4, something like that, which means the square root of 2 over 2 is less than 1. Okay, so it's always a possibility in these trig equations that you get an equation with no solution. All right, think about why this has no solution. Sine and cosine are never bigger than 1. Right, on a graph of sine or cosine, I'll graph, since I'm working with cosecant, I'll graph sine. Sine looks like this, which means cosecant looks like this. Not sure if that's showing up very well. Just make that white. Okay, so while sine and cosine never go above 1 or below -1, secant and cosecant never get within 1 of the x-axis. So saying where does cosecant equal this number less than 1, or excuse me, greater than -1, I should say, that's never going to happen, so no solution. So always watch out for ones that have no solutions. That tripped up some people on our inverse trig function test. All right, so one more with a secant that is going to work out. Let me start by adding 5 to both sides. And again, I'm going to go ahead and add 10 halves over here. You can see the way these problems work in this particular program. The fraction you add is going to just cancel with that number to work out nicely. So we get negative square root of 3 over 2 equals negative 3/4 secant theta. Still working on isolating the trig function. I'm going to multiply by negative 4/3 to cancel the negative 3/4, and I get positive 4 times the square root of 3 over 6 equals secant theta, or 2 radical 3 over 3 equals secant theta. And that should be a common, a familiar value, 2 radical 3 over 3. Not as familiar as the other ones, but when we start flipping them over and rationalizing, this is what we can get. So at this point, what I want to do is realize that secant is the reciprocal of cosine. So if secant equals this value, cosine must equal 3 over 2 times the square root of 3. And that's not a fully familiar value of cosine, but if I rationalize it, I get 3 times the square root of 3, and on the bottom I get 2 times 3, which is 6. Simplify that, square root of 3 over 2. So you might have realized it was going to be the square root of 3 over 2 a while ago. Just don't take out too many steps. That's where mistakes can happen. So what this question boils down to is, where does cosine of theta equal square root of 3 over 2? So cosine x value square root of 3 over 2, that's going to happen at my two shorter, as in further in the x direction than up. So that's going to happen at 30 degrees and 330 degrees. Keep in mind where the answers should come from. 30 degrees or 330 degrees. So like I said, these are going to get a little more complex when we start changing the argument, when we change these thetas to other versions, theta plus minus values, things like that. But for now, just remember, isolate the radical, and then use your inverse trig functions. And that's going to do it. First day of solving trig equations. Young out.